Greetings, I'm Professor Seth Frey, and welcome to the demo for Module 7, where we're going to use Python to visit Instagram and automatically browse Instagram accounts, and then use the actual photos from Instagram to use machine learning and do other kinds of explorations of the photo data from that social media platform, Instagram. All of this is going to be towards answering a funny kind of question: can an algorithm be biased against you? And why is that a funny kind of question? Well, when we think of code, algorithms, we think of kind of cold, hard logic. We don't really think of an algorithm being laden with social biases or reflecting the kind of social values or social specifics of some cultural time, or of the ones that I have implicit in me, or that our society has baked into it. We kind of think of those as being in different categories. However, there is a route by which we can even systematically encode society's biases in algorithms, and we're going to see that in action all through our interaction with Instagram. Now, you're going to find, first we're going to run our boilerplate code, and you're going to find it's a little different than usual. Normally, I've kept it really short. I've tried to keep it down to one block, a couple lines, not too clear what those lines do. You've been kind of running them and taking it on faith. But at least they're short, and that keeps them from being intimidating. Now we've got a lot more boilerplate. Why is that? We've got all this stuff, and boy, is that scary. A whole bunch of it. Most of the notebook is boilerplate. Now, what's going on? Why is the boilerplate a lot bigger? Is it because there's more stuff to do? Maybe the algorithms we're going to run are more complex? They are kind of more complex than stuff we've done before, but that's not why. Other stuff we've done has been pretty complex. It's had a lot of code to get it working. However, I've insulated you from that code in the past, and now I'm no longer hiding it. So nothing scarier is really happening now than before. It's just you're being shown. It's sort of like driving a car around with the hood without a hood. You can see the engine now. You can see all this stuff. You still don't know how it works, but it's somehow scarier seeing it, not knowing how it works, than not seeing it and not knowing how it works. The car still runs. It still runs the same as it always ran. You're still as ignorant about how it ran, how it runs now as it was when it was hidden from you. But now you're at least less ignorant about how much is being hidden, and you're being given this opportunity to control your feeling of intimidation. That's 100% why I'm revealing the boilerplate now, is to help you manage that feeling of intimidation. So we're first going to run this block. It's going to install a bunch of stuff from the internet. It's rolling and doing all that stuff. Then we're going to do a bunch of imports, so we're taking code other people have written and building on top of that. I've got a bunch of code here for working with images as data, just like lists and strings and numbers. Images are data, and I have a bunch of code for making them easier to work with. I have a bunch of code specifically for dealing with Instagram. We're going to install something and then write a couple little custom functions that make it easier. You don't have to, here, boy, that's some ugly output. What does that mean? I barely know. You don't have to know that. You run it, you get it working, and that's all you have to do. You're managing, you're intimidated, you don't know what's going on, but you don't have to. I'm not expecting you to. I'm expecting you to be able to run the code and get value out of it. That's the purpose of these demos. Where I want comprehension is in the lessons. I want you to understand what's going on with those things. And we get to bridge the gap. We get to do useful stuff and understand things, even if not always in the same lesson. And on and on and on. I've also got code here for setting up computer vision that lets us take images as data and ask questions about images the same way we used to ask questions about strings. Is this word, is this letter in this string? Is this object in this list? We also are now going to get to ask, is this object in this image? And that's what computer vision does. Having set up these functions, gotten through the boilerplate, which we can kind of skim. We can be like, oh, there's a function that looks for cat faces. Here's a function that looks for person faces. It works by calling something called hasObject, which takes both an image and a type of detector, a face detector, a cat detector, That's what hasObject does. It takes an image, it takes a type of classifier, type of detector, and it does this magical, intimidating looking stuff to answer the question, is this type of thing in this image? And yeah, I mean, yeah, again, you get to skim, you can kind of get the gist if you want to, but you don't have to, just run it. Having done all that, we can now authenticate. So we need to upload our Instagram credentials that you've gone through the process of getting so that you can run this demo for yourself, accessing your own timeline and accessing the feeds of others through your own key and credentials. I'm going to run this. It's going to give us our upload box. We click that. I'm going to upload my own authentication text file to get my own credentials up. Now it says upload 1, which means we're allowed to run this. And when we run this, this is going to go to the internet and tell Instagram that we want to start interacting with it under our own personal Instagram account. Now, I'm going to run it and get no error. You might get some error. Specifically, you might get something called client checkpoint required error. You might get a couple other errors. The thing to do if that doesn't work, if you get in there at that point, is hop back on your browser, go to your Instagram account, and it's going to say, hey, you're going to get an error. You might even get an email. You'll get an email. You'll get a screen when you log in. It's going to be like, hey, we detected suspicious activity on your account. You normally, and basically what it's saying is you normally interact with Instagram through the browser, and now you try, and we just noticed you tried to access your account through Python, through code. And normally when that happens, most people don't interact with Instagram through code. The people who do tend to be bots. So we're worried that you're not really you. But in this rare case, it just so happens you really were you. You really are trying to interact with Instagram through code instead of through the browser. So you can reassure Instagram that it's you. You'll click a couple screens. You'll prove it's you. You might have to respond to an email or whatever. It'll get you through that process. And hopefully after that, you'll be able to rerun this line of code, boop, and you won't get an error message. If you keep getting error messages, I have a couple other workarounds for you. You can try out, be in touch if you continue to have trouble authenticating. So now, assuming all that works out, and I hope it does, now we get to play with Instagram. So a first great thing to do is access a feed. Here's a bunch of code. Oh my goodness, it's a lot of ugliness. Here's a bunch of other ugly code. Let's not worry about it, what it does. Let's just run it. Run. What I'm kind of putting together is we were able, from this username, Daily Overview is a feed, is a account on Instagram. It looks like we got 12 items. We got 12 things. Now we're going to loop through those items and print them out. We're going to print out the actual image. We're going to print an image here. And we're also going to print the caption with that image. Let's see what we get. Okay, these are all satellite photos. They're photos from above. And what we're getting at the bottom of every image is the caption associated with that image. Now, if you were going to go to Daily Overview's account, you would see the same content. It's sort of throwing me around. Okay, that was weird. All right, and this is the 12th thing we downloaded. If we were to go right now, we would see the same content. So we're, again, pretending to be, we're doing everything we could do through the browser, through code. We're able to equal, and then we're going to go beyond just equaling what we can do in the browser, surpassing it, do stuff we couldn't do because we have programmatic access to social media. All right, I could have done that for some other accounts. Here's a retro Hollywood account, Golden Age. This was Hollywood. Shows old-timey photos. Got Cary Grant in there. Who else we got? Marilyn Monroe, of course. Nightmare Before Christmas, Dick Van Dyke, and on and on and on. Great stuff. Oh, Fred Astaire, of course. Spartacus. And we also got Lagos Street Style. I mean, any account you want to type in, we can get what's going on that account. I'm putting in a 1.2 second pause between photos to give us sort of time to see what's going on. You can shorten that or lengthen it just to play around, or you don't have to put it there at all. If you want to, I'm showing you photos one by one, like a slideshow. If you just want them all laid out, all strung out, we could do it like this. What I would do is between photos, I'm clearing the output. We can comment that out. And then I'm also just going to turn off the sleep. So there's no pause. We're no longer going to clear things, clear every photo before showing the next, and we're no longer going to pause. And what will happen now when I run it is we'll just get all 12 photos stacked on top of each other. So I'm going to scroll down, and here they are with their posts. If you want to slow things down, you could do it that way. All right, great. So again, this is just some code that lets us browse Instagram through code, which is, again, showing us an interesting view, showing us a little bit under the hood and opening up some possibilities, actually, for interacting with Instagram. You've been followed by bots or messaged by bots or approached by bots, and you probably follow bots without knowing it. And they've always been this mysterious thing that, we don't know how that works and what they are, what it means. You know now, because now you're a bot. You're on the other side. And here's what a bot sees when they interact with Instagram. I'm going to look, so items was about, when we run that command, we get the last 12 posts by default. So I'm just going to look at the 12th item, at this last item right here, okay? This woman and this content. When we're going to pretty print the nested dictionary that is an Instagram post. An Instagram post at the end of the day is a nested dictionary, and here's all the information about it. There's a lot of information in the caption about what the content was, a lot about who the user was who posted it. We have information about how it's been interacted with, how many comments there are, if likes are enabled or disabled. We have more and more. We have stuff on every single user who's interacted with it in one way or another. This user's interacted with it. This user's interacted with it. Or maybe they're tagged in it. I haven't looked closely. Maybe they're tagged in it. Maybe they replied. And so we have like the height and width of the photo. So we have information about the photo separate from the photo. We have in here a URL of the photo. Here it says height 557. So I'm just guessing here. I'm going to guess that this is a small version of the photo and that height was 1671. This is a large version of the same photo. We can try that out. Let's see. Yeah, okay, there's a large version of a photo, and then here is, let's see if we get the same photo but smaller version. Yeah, same photo, smaller version, right? So this is how it's represented. The photo's not stored in, you would think like the core of Instagram is sharing photos. You'd think that the thing that an Instagram post is, a major part of that would be the photo. But the photo itself is not in the nested dictionary representing the post. It's merely linked to. There's a pointer, there's an address of the images and various versions of the image. An Instagram post is not one image. It's a collection of links to various versions of the image, all of which are useful in different contexts as you display social media content in different contexts, on a computer versus on a phone, this type of phone versus that type of phone, big old phone, little tiny phone. Instagram, being social media, has to adapt to all these different ways it's viewed, and so it carries in itself all this information about how to quickly adapt to those different contexts. And that is what an Instagram post is, nested dictionary. So, this is just the beginning of being a bot. Our bot, this stuff we've done so far, it's not pushing to Instagram. It's not doing anything on Instagram. It's just reading. It's a passive bot. It's a reading bot rather than a doing bot. But you can do stuff on Instagram. Now, I'm giving you kind of ideas of the kinds of things you can do interacting in code with Instagram. I actually haven't really taught you enough to give you the confidence or the tools to really try. I don't expect you to be able to do those things, but I do want to plant the seeds of what becomes possible when you can interact with code through the internet. And with that is a great transition into object detection. So object detection is a part of computer vision. Computer vision means code that instead of reading text or whatever, or numbers, reads images. Computer vision itself is a part of artificial intelligence. And artificial intelligence, we can kind of think of it as having two branches. There's the part where we logically describe the world and expect things to interact with our logical representation. We sort of tell a robot how the world is, and it doesn't interact with the world so much as it interacts with what we told it. That's sort of a top-down, logically driven. There's this other approach that's becoming more and more and more popular. You maybe heard of it, machine learning, where we don't tell the machine how the world is. We show it lots of examples of the world, and it learns the structure of the world in this more bottom-up way. There have been big advances in machine learning in the past decade, and we can do really impressive things now. So, for example, you've already seen a cat detector. We're going to break out a face detector. So I've got here a URL for this picture of Margaret Thatcher from Wikipedia. We can plug that URL. I just Wikipedia a person and took the image on their article and clicked on it and got a URL that ended in .png or .gif or .jpeg, whatever. It ends in some actual image. It's the address of an image. It's not the address of a page that has an image in it. And that gave us this variable, which is coding the image into a variable. Then we can print the image, the same thing. And here we get Margaret Thatcher, this picture of her. Now we have a face detector, so we're going to run the face detector, run the image against the face detector, and we're going to print out this different version of the same image. It's going to be the same image, but it's going to have little boxes around every face it found. Now, there's only one face in this photo, so we should expect to get just one box. And there we go. Oh, wait. It actually, the face detector is not perfect. It was trained on positive and negative examples of faces, but a lot of those examples are dirty. It's hard. This is a difficult task to identify faces. So the face detector, it's going to sometimes have misses. It's going to be presented with things that are faces, but it's not going to recognize them as faces. It's not going to draw a blue box around where the face is. And that's one type of error that's possible, is a miss. There's a second type of error that's possible. It's called a false positive, where we see a face where there is no face. We see a face in the pin. We see a face in the waddle. So there's three faces in this picture according to the algorithm. I give you another function here, has person face. It doesn't return an image, it returns true or false. And it's useful, we could put it in an if statement. Let's say I'm writing an Instagram bot and my friends are starting to grow up, so there's lots of baby pictures. I have a baby detector. I don't want to respond. I'm obliged, I socially have to, every time someone puts a baby photo up, I have to be like, oh, that's so cute. But I'm kind of getting bored of it. So I write this bot. It scans all my friends' feeds. It runs if has baby face. And if a photo has a baby face in it, I have some comment like, oh my gosh, that's so cute. I think that's the cutest thing ever. Heart, 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 emoji, emoji, emoji. And then you seem like a really good engaged friend when really you didn't even have to think about it. It's running in the background. This is the type of thing that becomes possible when you can read images like strings or numbers or variables or any of the other Python objects we've interacted with. So computer vision plus code programmatic access to social media becomes really powerful and fun and exciting and cute. Okay, we can be critical of the classifier. We can be like, oh, it's obviously not very good if it thought that waddle was a face. But maybe that's not fair. For one, we could go one direction. I could sort of look I can kind of see. Do I see a face in there? It looks kind of grumpy, maybe. So that's one option is see a face in there, and another option is to be like, well, honestly, humans have false positives too. We see faces and things all the time. Maybe there's actually a lot of these accounts on Instagram. These people post photos of things that look like faces. We've got this this PETA that looks like a dog. We've got smiley angel food cake. We've got a smiley loaf, smiley lemon raspberry loaf. We've got a head that looks like a face. That's pretty good. That's awful. Oh my goodness. Okay, the bike helmet is looks like an adorable little lemur friend. Oh. No, that's gotta be Photoshop. That's not even real. Okay, yeah, hilarious. Runny nose too, beautiful. And so on. I mean, you get it. Blah, 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 blah. Here we've got a toast that looks like a face. Oh. Yeah, I said you get it as if I was going to move on, but I'm like, I cannot get away. That backpack. I could just do this all day. Wait, this is supposed to be 12. I feel like it's still going. Whoa, creepy. That looks like a floating head. You guys don't want to be watching me watch Instagram, so maybe we should move along. How's this still going? Okay, it pulled 18. I don't know why. Okay, so here's a question. Is for each of those images, we can check to see if there's a face. We can see. And while we saw a face in every single one of those, the algorithm didn't see a face in any of those. So arguably, in some sense, I mean, this is not totally legitimate to argue. I'm being a little bit silly here, but there's kind of a claim here that except for right here, this blue box here, where it did see a face in this toast, the algorithm did a better job at not seeing things that aren't there, what you call apophenia or pareidolia in humans. It did a better job than we do of not trying to see faces everywhere. See, I'm looking for these falses. False. We out of the 18, we just got one true. We found the algorithm saw one face. We saw 18 out of 18 faces. All right, and so we can use the face detector actually to ask lots of interesting questions, including going back to our original question: can an algorithm be biased? So again, if an algorithm is this purely logical, rational thing where I've written my if statements and for loops and I've written in instructions to the algorithm the logical way to behave, and if that logical way is really logical and it's really free of social bias, then the answer is no. I mean, that's a lot of ifs, but assuming all those ifs hold, the answer is no. The algorithm can't be biased. It's not taking information new. It's a decision that's based on social biases, so it won't. However, that was that logical branch of AI. We got this whole other branch of AI, which is the machine learning, where instead of teaching, sort of writing down the logic of behavior to the algorithm, what you call good old-fashioned AI that was really big in the 50s and 60s and 70s and really represents the beginning of AI, you have this transition over time to more data-driven AI, where the machine teaches itself, where you don't give it instructions, you don't give it logic. You give it data and examples, and it learns from the data and examples you've given it the patterns to look for. Okay, so here's where bias comes in. If the data you're giving it are biased, if I'm teaching it, for example, to recognize faces off of photos from Instagram, then my face detector isn't going to be like a general universal face detector. It's in some sense just going to be an Instagram face detector. And if Instagram has certain biases, maybe it's biased towards taking shots from a certain angle or of a certain type of person, maybe younger people. Maybe it's biased towards recognizing younger people instead of older people, or some demographic. If people from one country don't use it as much as another, it might be less good at recognizing those faces. And we get to see this in action. So I want to test our face detector in the sort of the cleanest environment. This face detector is ideal. It can't detect like any face anywhere. It's really suited to detecting faces kind of like close, like in this kind of frame, head on. If we think about, well, does Instagram have any examples of feeds that are just like close up, straight on faces? It turns out there's this whole class of makeup accounts. Makeup accounts are really good at providing the type of stimulus that the face detector is going to be good at. Additionally, there's makeup accounts for lots of different types of people. So I've got here Lisa Eldridge Makeup, whose work is mostly on white women. And now I've also got the account. So this is a bunch of code. This is a bunch of code. This is the exact same code. The only thing that's different is I've got a different account here. Dark Skin Women Makeup is a different makeup account, with also tends to be front facing. front-facing close-up images, but of dark-skinned women. We're just going to run both of these codes. What we're doing is we're retrieving a bunch of items from Instagram. This went to the internet. We don't go to the internet in the second block. There's no more rocket ships. We're going to go through the items we got one by one, print them out, and run face detection on them, and kind of count. Out of the 12 images we pulled down, or 18, I forget what it is, what proportion of them had, we know they all have faces in them. They pretty much all have faces. There's some exceptions that we'll see. What proportion had faces detected? So essentially, what's our miss rate? And my hypothesis is going to be that because I haven't showed you this, but I know what the training data looks like for our face detection algorithm. I know that it reflected, that it was, actually I'll get to that, that's some punchline, but in the meantime I'm just going to predict there's bias, and it's going to be biased towards white people and white men, and that it will be less good at detecting faces, real faces, from people who don't reflect that demographic. So we've got here, that's actually not a face. This is a face, and no face was found. So we're at 0 for 2, 0 for 3. We've got face detected here, 2 faces, but that'll just count as 1. There's no face here. Face found, blue square, no blue square. Oh, we've got some dark-skinned women, actually. In the white face account, we've got, that's not a face. Faces found. Okay, so we found 6 out of 12. That's pretty good. It's not that good, but remember that out of the 12, about 3 didn't have a face in them at all. So it's really 6 out of 9, which is 2/3, which is better. Okay, so now let's do. So we've got 2/3. Am I right? 2/3. Let's see. That's no face. So I'm going to subtract 1. No face. No face. So yeah, 6 out of 9, 2/3, pretty good. All right, now let's run the exact same code on a different account. Okay, so we've got no face. We've got a face, so that's 1 out of 12. Oh my goodness, it's scrolling awkwardly. No face, real no face, no face. 2, we've got 2 faces. Miss. So we only found 2 out of 12 faces. Again, it looked like, I'm sorry, how many didn't actually have a face? 1 didn't have a face. So it's not 2 out of 12, it's 2 out of 11. 2 out of 11, 1, 2, 3, 4, 5, 6, 7. It kind of skips some. So we're going to say we detected 2 faces out of 7. I only saw 6. 2 faces out of 6, that's 1/3. So the exact same face detector, the exact same kind of account, different angles. You'd have to run this on more than 12 data points. You'd have to run this on lots and lots of photos to really be 100% confident there really is a difference. But on the surface of things, sort of in the capacity of a superficial, really quick, throw-together demo that you can run, there seems to be bias. The same classifier seems to be better at detecting the faces of white women than black women. Even in a deal environment where we have a high proportion of like closely cropped front-facing face photos. So what's going on? How is this? What does this have to do with social bias again? Well, the face detector we're using was machine learned. It was trained on examples of faces. It wasn't trained on a representative examples. It's not like the people building this algorithm went around the world to try to find all the different kinds of people and take photos of them. No, they went around their office. These people were working in, here they are. These are the people who were working in AT&T in the early 90s when this was developed. The person developing this technology went around bugging people, their coworkers, to sit down and take some photos, part of the training data set for this algorithm. And if you look, this is the entire training data set that this algorithm was trained on. And what we've got are, we've got one person who's not white right here and is a dude. And everyone else looks white. Now, if we look for women, I think I've counted, you can look yourself, I think I counted 4. So out of these, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, times 2 is 40. Out of these 40 faces, it looks like 10% are women, very underrepresented at AT&T in the engineering division in the 90s, and one black person, one non-white person. So we've got a severely biased data set. Of course the classifier is not going to be as good at detecting all types of faces. But you can imagine, let's start asking, like, what are things I could use this classifier for? Let's say, if there's any way that detecting a face somehow improves someone's economic opportunity, maybe I'm targeting college ads to people who I see a certain type of face photo, a certain type of face in their photo, then I'm going to systematically miss the people who are being systematically missed by the algorithm. Okay, so that's all the downside. That's algorithm bias. There is kind of a counterpoint here that we do have to acknowledge. There's only, again, 10% women, and 1 out of 40. I'm sorry, what's that? That's 2.5% non-white people, and 0% black female people. So there are no black women in this entire data set. So from that perspective, it actually it's a little bit impressive that the first algorithm, just the white women, got 2/3 correct, given how undersampled women were in this data set at all, and that we got 1/3 correct on black women, given that they're 100% unrepresented in this data set. So the point being, there is such a thing as like a human face. And the algorithm did pick up on some of the aspects of a human face, and that's nice. Nevertheless, these biases, they're not important because they just completely shut groups of people out. The fact that their effects are more subtle actually makes them more insidious, because it can be harder to even detect that this is happening. It's not so blatant. It sort of pops up in the edges, these subtle biases. And so it cuts both ways that the algorithm's a little bit good. It's not completely awful. But in exactly the way that a lot of bias is. A lot of bias isn't totally overt. A lot of bias is subtle. And the algorithm's reflecting that exact same subtlety. Okay, so we did a lot of stuff. We got an introduction to the Instagram API in Python. We ran a bunch of code that let us explore feeds. But rather than just matching what we could have done in a browser, we went beyond that. We started to treat images as data. We started to look for objects in images with the same kind of ease that we were looking for words in strings or vowels in letters. And all towards this larger lesson about what it means for an algorithm to reflect social biases, especially in the age of machine learning. So again, that's a lot of stuff. I hope you got a lot out of it, and thank you very much.